Hello everyone, welcome to lesson 114 day 2. We're going to be talking about points of intersection today. So our content goals, we want to find the points of intersection between two functions using multiple representations, such as our equations, our tables, and our graphs. We should be able to find points of intersection. And we also want to have technology aid us in finding the points of intersection. So I'm going to be showing you how to use your calculator to do this today. All right, so for today, imagine that we have two functions that represent two different parabolas. In some applications, it's handy to know when these functions are equal to each other. When two functions are equal to each other, we call these the points of intersection, right? So if you can imagine, you have two different functions on a graph. They are going to intersect each other. That's when they are equal. So we call those points at which those functions are equal the points of intersection. All right, so today we need to be able to figure out how to find the points of intersection or when the functions are equal using a table, graph, or an equation. So I'm going to start off with showing you how to do this on a graph. So we have our two functions here. I named the first one f of x. I named the second one g of x. And I have produced the graph here, and I actually produced this using the TI-84 calculator. So I'm going to show you how to get this same exact graph here. And I have the step-by-step instructions listed over here. So as you watch me, you can read through these. You might want to make sure that you have these somewhere accessible, because if we have a question like on the quiz or something and you need to reference back to this because you forgot how to do it, this is your step-by-step right over here. Right. So I'm going to pull up my calculator and let's move that over here. We'll turn it on. There we go. All right, so the first thing that we want to do is we want to go to y equals, and we're going to enter in our two functions in y1 and in y2. So we're putting in both functions at the same time. One goes into y1, one goes into y2. All right, you can see how I have mine entered in already. So I have f of x entered into y1. I have g of x entered into y2. If you need a minute, this would be a good time to pause the video while you enter those into your calculator before moving on to the next step. All right, so if you are ready and you have your functions entered into the calculator, the next thing we're going to do is we're going to hit graph. And you should see your blue parabola, that's your f of x, and then you should see a second red parabola right here pop up, and that is your g of x. And I'm actually going to pull up the big screen here. There we go, so we can get a closer look at what's going on. Let's see, let's put it over here. And I'll move this over here. Okay. So you'll notice what we're looking for, the points of intersection, we're looking for when the red parabola and the blue parabola cross over each other. That's when they are going to be equal to each other. So it's kind of hard to see with the way that our viewing window is now. So we're going to use an option called zoom. All right, so we're going to go over here and hit the zoom button. And we want to zoom out a little bit so you can get a bigger picture of those parabolas. So I'm going to go down to option 3 and hit enter. And you'll see your cursor kind of blinking here in the middle. All right. What I want you to do is just push the up button on your calculator and move that cursor up. Okay, so move it up towards the blue parabola. Try and get above the blue parabola if you can. So you want your cursor to be about right here, and then I want you to go ahead and hit the enter button, and it should zoom out while recentering the screen where we had that cursor. There we go. So now we can see the blue parabola. And then there's our red parabola, and we can see a point of intersection here and a point of intersection here. What we would like to know is the exact location of both of these points of intersection. So I'm going to start by finding the point of intersection on the left. So the way that we do that is we're going to use a function on our calculator called the intersection command. So we're going to hit second and then trace. You'll see calc is in blue, so this is called the calc menu. And when we go to that menu, you'll see an option here. It says intersect. That's option 5. So you can just hit the 5 and it'll start trying to find the intersection for you. So down here at the bottom, it's going to say first curve. All right, and what you want to do is you just want to move your cursor over like that so it's kind of close to the intersection that you're trying to find, and just hit enter. And then you'll notice the second cursor jumps up to the red parabola. Okay, and again, you just want to make sure that's close to the intersection that you're trying to find. And right now it's close enough. So when it says second curve, you just hit enter. And then the last thing it's going to say is guess. Yep, we can go ahead and guess at this point. Just hit enter one more time. And you'll notice that the cursor now locks in on the intersection, and you can see the coordinates given to you down here. So one of our intersections is located at -2, 24. So I'm going to write that down. Okay. And that would be this intersection point right here. So now we need to find the other one that's located over here. So I'm going to repeat the process for the other intersection point. Okay. So I'm going to go back to second trace, and I'm going to go down to my intersection command. I'm going to hit enter. And notice my cursor is over here by this intersection, so I'm going to move it left or right until it gets close to this one. So I'm just going to hit the right button, and you'll see that cursor move over. So we're going to get close to that second intersection just like this. It doesn't have to be right on it, just close, and hit enter. And again, you'll see that second cursor pop up on the red parabola, and I'm going to move it so about right there is fine, just like that. And I'm going to hit enter, and it'll say guess. So we'll hit enter one more time, and it locks in on the intersection, and we see our second intersection point here is at 3, 9. And there we go. So those are the points of intersections. Those are the 2 points when our functions are equal to each other. Okay? So that's how you do it on a graph. And that's how technology can help you do that. That way you don't have to graph those parabolas by hand and hope that you drew it well enough to get the intersection points to be accurate. The calculator can take care of that for you. All right, so the next thing we're going to do is we're going to find intersection points using the table. So remember, our table feature on the calculator can also be handy. I will say before we do this one that the table is handy if the intersection points happen to be integers, right? So notice how these were all nice whole numbers or integer numbers. Sometimes intersection points happen at messy points, in which case the graphing method is going to be better because the points of intersection will not show up on the table. All right, but let me show you how to use the table so you can find those intersection points. So you would go and you would enter your functions into y1 and y2, which we have already done, so hopefully they're still saved in there. And then instead of going to our graph, we're going to hit second and then graph to get to the table. Okay. And you'll notice that we have 2 columns here, one for y1 and one for y2. The y1 column represents all of the outputs from f of x, right, our first function, and y2 represents all of the outputs from our second function, which was g of x. And since we're looking for these 2 functions to be equal to each other, we're going to look through the table and we're going to find when the outputs are the same. Right? So if I go down here and I start going through these inputs and outputs, I notice that when x is -2, my outputs are exactly the same. We get an output of 24. And the same thing occurs at 3. You'll notice that both of the outputs are 9. Okay? So we have a point of intersection here in our table, and we have a point of intersection here in our table. So we would say again the points of intersection are at -2, 24 and 3, 9, which we've already written up here. All right. The last method here for finding points of intersection is going to be to use the equations that we were given. All right, so this is an algebraic method for finding these. And again, we use the premise that if we're trying to find a point of intersection, we are trying to find when these 2 functions are equal to each other. So I'm going to write that algebraically. I'm going to take f of x, which is 2x squared minus 5x plus 6, and I want that to be equal to g of x, which is -2x squared minus x plus 30. So I set them equal to each other. And then we are going to solve this equation using algebra. Okay. So what I'm going to do is I'm going to start by drawing a line, just like this. and I'm going to get everything on one side, right? So I'm going to move everything from the right-hand side of the equation over to the left-hand side of the equation. All right, so I'm going to start with the 2x squared. I'm going to add 2x squared to both sides because that would be the opposite of negative 2x squared. So I'm going to say plus 2x squared, right? And when I add 2x squared on both sides, I get 4x squared over here minus 5x plus 6. On the right hand side, these guys cancel, and all that we're left with is negative x plus 30. So now I'm going to move the negative x over. So I got to add x to both sides. So those cancel. And we're going to get 4x squared. Now negative 5x plus x is negative 4x plus 6. And that plus 6 is still there. And all that's left over here is 30. Okay. So continuing on, now I'm going to move the 30 over to the left-hand side. So I'm going to say minus 30 and minus 30. Right? Whatever I do on one side, I have to do on the other. So these are gone. That's a 0. Right? And that's what we want. Right? We want it to be equal to 0. So now I've got 4x squared minus 4x, and then we have a positive 6 minus 30, so that's going to be minus 24. Here we go. Okay, so we've got everything on one side, and what you'll notice now is that we have a quadratic equation set equal to 0, so we can use our quadratic formula, which we learned about yesterday, to find our two solutions to this thing, right? So I'm going to start by identifying what A, B, and C are. Right? So A is going to be 4, that's the number in front of x squared. B is going to be negative 4, that's the number in front of x, and then the number on the end, the constant, is negative 24. And then I'm going to start my quadratic formula. So we've got a negative, negative 4, right? There's a negative built into the formula and a negative attached to the 4. So there's going to be two of them. Plus or minus, square root. And I'm going to do negative 4 squared minus 4ac, so 4 times negative 24, all over 2 times a, right? So we have 2 times 4, right? And this will give me my solutions for x here. Okay. So again, the method that I taught in the video yesterday is just to find something easy to do and do one thing at a time. So negative 4 turns into positive 4. That was easy. Okay. Negative 4 squared, that's easy. That's positive 16. And then I can do this multiplication here. I might need my calculator for this one. No problem. So I'm going to go here and I'm going to say 4 times 4 times 24. Got 384, and I have a negative here and a negative here, so those will become positive. So I'm going to have plus 384 all over, and then 2 times 4 is easy. I can do that. That's 8. Okay. So you notice I just do it one step at a time. I try to use the calculator as little as possible. So an easy thing to do here would be the 16 plus 384. That's 400. And this is all over 8. Okay. So now I'm thinking I probably need to do this square root of 400. So I might need my calculator for that one. All right, so I'm going to do square root of 400 and see what I get. I got 20, so that worked out nicely. So we got 4 plus or minus 20 over 8. And this is where we're going to branch off into the two possible solutions so that we can handle this plus or minus. So I've got 4 plus 20 over 8, and then I'm going to have 4 minus 20 over 8. All right, so this becomes 24 over 8, and this becomes negative 16 over 8. So this becomes 3, and this becomes negative 2. All right. So now to figure out if we're looking for points of intersection, I now have 2 points. One has a 3 in the x-coordinate, one has a negative 2 in the x-coordinate. And if we look at our previous points of intersection that we found before, right, there's our 3, there's our -2, and we already know what the y values are going to be. But if we didn't have the graph or the table, what we would do is we would take that 3 and -2 and we would plug it into either one of these functions to figure out what the output or the y value is going to be. But I will spare you that, right? We don't need to do that because we figured it out from the table and the graph already. So we know that when we put a 3 in, we're going to get a 9 out. And we know that when we put a -2 in, we are going to get, 24. We're going to get 24 out. So these become our points of intersection. And you are probably thinking that was a lot harder than just looking at the graph or the table, and you would be correct. But there are times when the algebraic method is better than the table or the graph because it does get us very exact, precise solutions, whereas sometimes on the graph or the table, if we don't land on nice integer solutions, it will give us a rounded answer or something of that nature. So we get very exact, precise answers from the algebraic method versus the other methods, which is why we learn how to do it. All right, guys, that's it for today's lesson. Give the practice problems a try. Good luck.